everybody, it's Mrs. Mancuso with another Chemistry Regents review. Today we're going to talk about nonmetals. So nonmetals are found on the right side of the periodic table. So again, there's my staircase, and so these are my nonmetals. Hydrogen is also a nonmetal over here, which is why it's separated. It belongs here because it has one valence, but it's not a metal, so it's separated. It's a nonmetal. So those are my nonmetals. Nonmetals tend to go through reduction. And remember, reduction is gaining electrons. So if you look at any of their charges, they are negative. Their most common oxidation states are negative. So if you gain electrons, you gain a negative charge. So I could show F, fluorine, plus 1 electron would become F minus 1. So that's my reduction half reaction. That's what happens to my nonmetals. And when you gain an electron, you gain radius. That means your size increases. So fluorine was a pretty small atom because it has 9 protons in the center, and that holds its electrons pretty close. But if you gain one more, you get a little bit bigger. So that's why the radius changes and gains a little. All right, some properties of nonmetals. First of all, they are poor conductors. They are not good at conducting. The metals are most likely to lose electrons and pass them between each other, so they have mobile charged particles. These tend to be poor conductors. They also have, they simply don't have the properties that metals have. So in the last video, we talked about these properties of metals being shiny, malleable, ductile, and conductors. Nonmetals would not have these properties. Okay, so some properties that they do have, they tend to be brittle, or some of them are gases. I mean, if you look at this right of the periodic table, the majority of these things are actually gases. So only if they happen to be a solid might they be brittle. These ones, obviously all of my noble gases, and fluorine and chlorine and bromine. Bromine's a liquid, but each of these are a gas, and oxygen. So tend to be that, which means they have really weak attractions between molecules as well. Other things about them, they tend to have high ionization energy. So ionization energy is the energy required to remove the outermost valence electron. So let's think about this. Here's fluorine. It's 2-7. It is 1 electron away from being like a noble gas, being super stable with 8 valence. There is no way you are going to take away one of those 7 valence electrons. So it has a very, very, very high ionization energy, meaning it would take so much energy to get that away. Over here, my left side losers have really low ionization energies because they just have 1 or 2 valence, and it's pretty much like, I know I always make atoms sound like they're real or they're human, but basically they're like, take it away. If you take it away, I will have my full octet. So left side losers, low ionization energy. Right side, high ionization energy. Another word I want to talk about is electronegativity and what that means. To be electronegative means that you're able to attract electrons. So again, if I think about my periodic table, these guys do not want to attract electrons. They have a large atom, so left side losers are large. They have low electronegativity and low ionization energy. They do not want to attract more electrons because, like group 1, they'd have to gain 7. Chances are you're not going to gain 7. Over here, right side, they tend to have high. Here, fluorine, it's the highest of all the elements. It's a 4.0. So where am I getting that number from? Flip this over, and here you can look up any atom's ionization energy and electronegativity. So fluorine, there it is with a 4.0. It is best at attracting electrons. That means it's really going to have pull to be able to get electrons from another atom. All right, thanks for joining me, and come again for more review.